July 6, 1998. New York's JFK Airport. Cathay Pacific Flight 889 prepares for takeoff. It's bound for Hong Kong, but it's about to fly into a great unknown. The pilots have made this trip hundreds of times before, but never like this. Because even as the plane lifts off in New York, in Hong Kong, the airport suddenly goes dark. It's not a power failure. This is an historic event. The culmination of nearly a decade of furious planning and construction. Hong Kong has just shut down one of the world's major international airports. And with planes en route, is moving the entire operation, staff and equipment, to a new one in only 7 hours. It's the final hurdle in a 7-year race to complete the largest, most ambitious civil engineering project of the 20th century. It all began in the 1980s, when Hong Kong faced a critical turning point. By then, it had become one of the world's great economies. But these towering skyscrapers masked a glaring weakness. Kai Tak Airport. Dangerous and outdated, the airport sat crammed in the heart of the city. Kai Tak made every flight into Hong Kong a white-knuckle flirtation with disaster, forcing massive jumbo jets to steer past mountains and skim the tops of apartment buildings in order to reach the tarmac. Six accidents or near misses occurred at Kai Tak in the last 2 decades. In this accident, in 1993, the plane overshot the runway, injuring 22 and killing 2. And there was another enormous problem: cargo. The airport had only one runway. It had become a major bottleneck to global trade.
Hong Kong could not continue with its existing airport in terms of passengers, and even more important in terms of cargo. Hong Kong is the biggest international airport in terms of cargo in the world.
With billions of dollars at stake, Hong Kong needed a new airport. But where? The city was jam-packed, without a shred of available land. There was only one possibility: build the airport at sea. The proposal was mind-boggling. It called for the creation of a new island in the South China Sea. On that island, a massive new air facility, capable of handling the world's largest jets and the single largest passenger terminal on Earth. But this massive airport was itself only a small fraction of the overall project. To get passengers and freight to and from the airport quickly, the plan also called for 22 miles of new superhighways and tunnels, and a new high-speed rail system, as well as the world's longest double-decker suspension bridge. Hong Kong's planners knew that without a new airport, the city would soon no longer be competitive in the global marketplace. But age-old politics threatened to stop the project in its tracks. Hong Kong, a British possession, was about to be returned to China. More than a century earlier, during the Opium Wars, Britain had captured Hong Kong from China. But as part of the peace treaty, Britain had agreed to return the territory after 100 years. Now that due date was a mere 7 years away. Many dreaded the impending handover, fearing that China would put an abrupt end to Hong Kong's capitalist economy. If the new airport was still unfinished when they took over, would the Chinese agree to complete it? There was only one way to ensure that the airport would be done. Finish it before the takeover.
The airport was the pawn in this huge game of chess, the political chess that was going on.
Engineers projected that under normal conditions, the project could take between 10 and 20 years. Now they had less than 7. In September 1991, the race was on. The first challenge: create enough level ground for the airport. Engineers had their eyes on a pair of rocky little islands called Chek Lap Kok and Lam Chau, 16 miles from downtown. But neither one of the islands was big enough to house the airport by itself. And they both were far too mountainous for long, flat runways. The solution? First, the mountains had to go. With towering heaps of blasted rock as far as the eye could see, an army of workers was brought in. Their mission? Move 200 million tons of rock. Commanding giant earth movers, they demolished the landscape. Carting away hundreds of millions of tons of rubble. But all that material would not go to waste. It would soon be recycled as fill to turn the 2 small islands into a single larger one. But before that could happen, the sea floor needed to be cleared. For this task, a fleet of the world's largest underwater dredgers arrived on the scene. Like giant vacuum cleaners, their underwater hoses scoured the ocean bottom, removing a layer of soft mud 40 feet thick to expose the stable rock below. The cleared seabed provided a solid base for what was to come next. A layer of sand, followed by the pulverized remains of the island's mountains. With every truckload, the 1.5-mile gap between the 2 small islands grew steadily smaller.
Everybody was under extraordinary time pressure. It was one of the world's biggest land-moving exercises in the history of the world.
Working day and night, inch by inch, workers on land and sea slowly turned two islands into one. By the time they finished, the workers had moved 600 million tons of earth, enough to fill the Roman Colosseum 200 times over. As the airport island was taking shape, construction crews had begun the daunting task of connecting the island to the city. For new tunnels, bridges, and highways to be built across 22 miles of land and water. Almost immediately, engineers ran into a problem: finding a way out of downtown across Victoria Harbor. Two automobile tunnels had already been built in the harbor decades earlier, but they were now overloaded with traffic, sometimes causing 2-hour traffic jams at rush hour. A third, much larger tunnel was needed. It had to be wide enough to carry 6 new lanes of traffic and long enough to span the 1-mile underwater crossing. Engineers devised a plan to assemble the tunnel underwater from mammoth concrete and steel sections. The sections were manufactured at a harborside quarry 10 miles from the final tunnel location. Each one weighed 35,000 tons when finished, as heavy as a fully loaded ocean liner. When a section was completed, builders capped both ends with watertight seals and then flooded the quarry. The massive tunnel sections were then floated out into the harbor. Once at the final location, the seals were broken, flooding the section and causing it to sink. Powerful hydraulic jacks pulled the sections together and created a watertight seal. Then, builders made the final connections from the inside, and the tunnel was complete. It lay more than 50 feet underwater and stretched for more than a mile, connecting the busy island of Hong Kong to the mainland. With one waterway conquered, an even greater challenge loomed. Along the proposed route from downtown Hong Kong to the airport, there was another major body of water to cross. A 3-mile span from the mainland to North Lantau Island. Initially, planners hoped to build another underwater tunnel here to carry airport traffic. But the channel turned out to be too deep, and heavy shipping traffic at the surface would have made underwater construction far too dangerous. So engineers had to come up with another solution. It was as bold as it was breathtaking. They proposed not one, but 2 massive bridges, long enough to span the waterways and high enough to allow even the most gargantuan ships to pass underneath. The longer span, more than 1.5 miles long, would be one of the longest suspension bridges in the world. But it was a risky proposal. the bridge would need to withstand one of the most destructive forces on Earth: typhoons. Packing devastating winds up to 200 miles per hour. As many as 8 typhoons slam into Hong Kong each summer. Any bridge built here would have to first prove its strength. To understand how winds would affect the structure, engineers first created computer models. This model simulates the motion of the suspension bridge in a 40-mile-an-hour wind, amplified 1,000 times, allowing engineers to identify potential design flaws. Using the data collected, engineers next built a detailed scale model. They placed it in a high-speed wind tunnel and subjected it to a simulated Category 10 typhoon. The results were disturbing. The bridge would become dangerously unstable in high winds. Designers